Hello, this is Professor Kyle Mack, and you are watching 12-2 Lesson Intro in 5 minutes or less. All right, so we're going to do a quick review of triangle congruence. You have the side-side-side postulate, the side-angle-side postulate, which are two that we looked very closely at in 12-1. And then we have the angle-side-angle postulate. The angle-side-angle postulate is shown right here. And what we see is that an angle, a side, and then an angle can be used to create a congruent triangle. We also can use angle, angle, side. Here's angle, angle, side to create a congruent triangle. The four centers of a triangle are the incenter, the circumcenter, orthocenter, and centroid. Now, each of these are used in various different ways, but they are found using several different line segments that can be either created from the sides or the angles of the triangle. So the first is the incenter. That is the intersection of all the angle bisectors. So what we're going to do is we're just going to look at this figure right here to better understand this. A1 has an angle bisector, which means that it's a line or a ray or line segment that splits the angle in half. And so if you have A2 and A3's angle bisectors, what we find is that they intersect right here. When they intersect, that is the center of a circle that can be drawn inside of the triangle. That is the largest circle. It will intersect each of the sides once. That is called inscribing the triangle. The circumcenter is the intersection of the perpendicular bisectors of all sides. So as you can see here, this is a perpendicular bisector because it splits the side in half and it intersects the side at a 90-degree angle. If you do all three of those, what you'll find is that they intersect at one location. Now, what's pretty cool about this is this actually doesn't necessarily have to be in the interior of the triangle. In some triangles, it's on the exterior. But what will happen is that will be the center of a circle that can be drawn that will include all three vertices of the triangle within the circle. That's called circumscribing the triangle. Now, the other two we're going to look at are not going to be as in-depth of a study, but I did want to show them to you anyway. Those are the orthocenter and centroid. The orthocenter is the intersection of the altitudes. The altitudes are kind of also known as the height of a triangle. What they do is they go from a vertex, and that line then intersects the opposite side at a 90-degree angle. When you connect all of those together or find the intersection, that is the orthocenter. The next thing that you can do is you can find the centroid. This is the intersection of the medians. A median is a point that splits the line segment in half. So it's like a bisector, but it's not perpendicular necessarily. And so point D is the bisector or the median point of A and B. But to finish the median, you have to go from that midpoint to the opposite vertex. When you do that for every side in their opposite vertex and connect those, what you'll find is you'll have an intersection point. That is the centroid. Another cool thing that you can know about these centers is that the orthocenter, centroid, and circumcenter all actually line up in a line in every single triangle. Another cool thing is if there is any distance between these, what will happen is the distance between the centroid and the circumcenter will be half of that between the orthocenter and the centroid in every single triangle. Now, there is one special situation where they all overlap. Not only does it the orthocenter and the centroid and the circumcenter that overlap, but also the incenter, and that's within an equilateral triangle. All right, then most of our time within our class meeting will be dedicated towards the properties of quadrilaterals. We're going to look at trapezoids, specifically isosceles trapezoids, parallelograms, concave and convex kites, rhombi, and squares. And what we're going to do is we're going to use what we've learned about the bisectors and some of the different constructions we've used, but also things like transversals of parallel lines and some of the properties we've learned from that. And then more importantly, some of the triangle properties and postulates. And what you're going to find is all of that information is what's used to understand certain properties that are related to quadrilaterals. This concludes the 12-2 lesson intro in 5 minutes or less.